So now we move on to quadratic inequalities. So in order to solve quadratic inequalities, the first step is to rearrange the inequality into the form ax squared plus bx plus c, and then whatever the inequality sign is, it isn't important, and then 0 on the other side. So ax squared plus bx plus c on one side and 0 on the other. The second step is to replace whatever the inequality sign is with an equal sign to make the very familiar ax squared plus bx plus c is equal to 0. And obviously we worked with this in the first two chapters and we're very familiar and comfortable with it. The third step is to find the roots, and the fourth step is to sketch a very quick and a very brief graph and compare this to the inequality we made in step 1. So let's use an example in order to make this a lot more easier to understand. So it's going to be framed in the same way. It's going to say find a set of values that satisfy, and we're going to use the inequality 2x squared plus 5x is greater than 3. So the first step is to rearrange this into the form ax squared plus bx plus c and then put equals onto the other side. So that's easy. We just do 2x squared plus 5x minus 3 is greater than 0. The second step is to replace the inequality sign with the equal sign. So we do 2x squared plus 5x minus 3 is equal to 0. And then we find the roots. You can do this by factorization or by using the calculator. I just use the calculator, and we get the roots as minus 3 and a half. And then we need to sketch the graph. So this just needs to be a very quick and very it doesn't need to be too accurate. So it's a positive parabola because we've got a positive coefficient of x squared, and we know the roots as minus 3 and a half, so we're going to draw the quadratic sort of looking like this. Yeah, that's quite good, where the root here is minus 3 and the root here is a half. Again, it doesn't need to be too accurate, it's not too to scale, but it's not that important. And then we need to compare this to the inequality that we made in step 1, which is here. Now the inequality in step 1 is saying that we need to find the values for which 2x squared plus 5x minus 3 is bigger than 0. And if you think about this, this is all the values in which the quadratic is above the x-axis. So all the values in which 2x squared plus 5x minus 3 is bigger than 0 are the values here, here, and here. These two parts here. These are when the quadratic is bigger than 0. And we need to find the set of values for when these values exist. And this is really easy to do because we have the roots. So we can actually find that 2x squared plus 5x minus 3 is bigger than 0 when x is less than minus 3, because remember it goes in this direction. So when x is less than minus 3, it's always positive. Or when x is greater than a half, because it goes in this direction, so everything above a half is going to be positive. The only values in which it's going to be negative are these values here, and these are the values that obviously we don't include in the set of values. Of course, we could write this in set notation. So this is really the first time that we use the or what looks like the u. So in set notation, it will be, I'll write it up here, x is a solution when x is less than minus 3, or, and then that's the u, and I'm going to do it down here because, actually no, I'll see if I can fill it up here. X is a solution when x is bigger than a half. And then these are the two ways that you can write the answers to this quadratic. Now, I mentioned in the previous video that you can solve quadratic inequalities by putting it into the calculator. So if you press menu / setup and you go all the way down to the B box this time, and you press, it's the inequality box, and you press equals on it, you press 2 for a second degree polynomial, and then it will come up with this list of 4 options, and then you need to look at the inequality that you've made in the first step, which is here, and you need to see which one applies to the one that is on the calculator. So in our example, it's going to be 1 because the quadratic is greater than 0. And then you're given a blank quadratic, and then you just put the values in. So we're going to put 2 as the coefficient of x squared. Remember, use equals to put in the values. And then 5, and then minus 3, and then you press equals, and then it's going to give us the same values that we've worked out for the question, where x is less than minus 3 or x is greater than a half. Now, I don't use this method as a way to answer this question on its own, because this question is fairly difficult, so the examiners will want you to write down a method in order for you to get any marks. So don't use this method on its own. You will need to learn the method that I just described here with the steps in order to find it out. But as I always say, the good thing about the calculator is after you've figured it out, you can put the question into the calculator, and if you get the same values out as you figured out, then you know that you've got the answer right. So here it's quite reassuring that we've got the same values as the calculator, because then we know that we've got the answer right. Okay, I'm going to do one more question in order to hopefully reconsider that and explain it some more if you need it. So let's use minus x squared plus 2x plus 3 is greater than or equal to 0. Well, the first step we don't need to do because it's already in the form that we need. It's already in the form ax squared plus bx plus c, and then an inequality sign, and then 0. The second step, we replace the inequality sign with the equal sign to get it in the more familiar form. And then we find the roots. So you can use a calculator, and I find them to be minus 1 and 3. Then the fourth step is to sketch the graph again. So knowing the roots are minus 1 and 3, remember that this is going to be a negative parabola this time because the coefficient of x squared is a negative number. We're going to find that the quadratic is probably going to look something like this here, where this here is minus 1 and this here is 3. Okay, so we need to find the values where, for our inequality, it is bigger than or equal to 0. It's bigger than or equal to 0, so it's above the x-axis. So it's going to be the values here. It's not going to be the values underneath because they're going to be negative. We need to find the values above, which are going to be the positive ones. And therefore, using the roots, we can find that the set of solutions is going to be when x is bigger or equal to minus 1, because remember, it can be equal to 0 as well, so it can be the root. Minus 1, 0 is the root. So x needs to be bigger than minus 1, but it needs to be less or equal to 3. Okay, and again we can write that in set notation. I'll do it up here again. We can write that as x is a solution when x is bigger than or equal to minus 1, but it is less than or equal to 3. Of course, you could use the and slash kind of n symbol from before, but in my personal opinion, you don't really need to. You could just do it this way, it's easier. And once again, you can use the calculator in order to check your answer, and that will give out the same values, the set of values that we found here. So that's a way to check that you've got the right answer.